All right, ladies and gentlemen, Mr. Hatfield here. I'd like to do a problem straight out of our notes to model it for you. This is going to be using the equation where atmospheric nitrogen reacts with atmospheric hydrogen, N2 plus H2, and it reacts in a 1:3 ratio, and it produces 2 moles of ammonia in H3. Now, what I'd like to do is I'd like to answer a question. The question I want to answer is if I have 10.1 grams of hydrogen, how many grams of ammonia can I manufacture? So that means I'm going to be starting with grams of one substance. I'm going to be ending with grams. And this is going to be a 3-step problem. The first step is we need to take the number of grams that are given for hydrogen gas, and we're going to need to convert it to moles. So I have an arrow going up, and I'm going to label it grams to moles. That's my first step. In the second step, I'm going to go from moles of hydrogen on the reactant side behind the arrow, and I'm going to go to moles of ammonia on the product side after the arrow. So I'll have this arrow on top that connects the moles of hydrogen with the moles of ammonia, a 3:2 ratio, and that's my second step. And if I stopped here, this would be a 2-step problem. But now I add a third step. I add a third step because I want my answer to be in grams of ammonia. And so I have this arrow pointed down. I'm going to label it moles to grams. Okay, so that's our map based upon the balanced equation. Now we're going to take our given and write it first. 10.1 grams H2. To convert it, I'm going to use the molar mass of H2. One hydrogen by itself is roughly 1.01, so 1 mole of ammonia, or rather 1 mole of hydrogen gas, H2, is going to be 2.02 grams for every mole of H2. And of course, we put the grams on the bottom here because our given was grams of hydrogen. So this is our first step that goes from grams to moles. Now we look at our mole ratio. We see that we have 3 moles of hydrogen gas, H2, on the reactant side, 2 moles of ammonia on the product side. Since we have moles of H2 on top of our second expression, it's got to be moles of H2 on the bottom of the next expression. So the 3 moles go here, and the 2 moles of ammonia go on the top here. Now for our last setup, we need to convert the moles of ammonia to grams. If we stop there, it would be a 2-step problem, but we're not going to stop there. And so if we look at this, this is 1 nitrogen, which is 14.07, and we have 3 hydrogens, which is about 3.03. So that turns out that to be about 17.1 grams of ammonia for every mole of ammonia. So that's our setup. And of course, grams of hydrogen will cancel, as will the moles of hydrogen and the moles of ammonia, and we just multiply. Product of the top divided by the product of the bottom. And so that's essentially 10.1 times 2 times 17.1 on the top, divided by 2.02 times 3 on the bottom. If we get done doing all the math, we find that we have 57 grams of ammonia. So this is an example of a 3-step problem. Again, you first have a balanced equation, then you map it, you write down your given, you'll use a conversion factor to get to the mole ratio, then you'll have a mole ratio, and then at the end you'll have another conversion factor to get back into some other unit, like as in this case, grams. And I hope this example is helpful.